Hi, welcome to another video, and this time we are going to discuss mutually exclusive events and how the unity is calculated depending on whether two events are mutually exclusive or not. So, first of all, let us start with the example of two events which are indeed mutually exclusive. Imagine that you toss a fair coin. So there are two possible outcomes for you. You can get head or you can get tail. If you get head, it means that you do not get tail. If you get a tail, it means that you do not get a head. So again, very intuitively, those two events are indeed mutually exclusive. You cannot have both in the same time if you want to speak informally. So here, when we calculate the unity of those two events, and we will read it as probability of getting head or tail, because this is how you interpret the notion of unity logically. This it will be equal to the simple sum of probability of getting head and probability of getting tail. So the probability of getting head or tail is equal to 100%. Like you will get something, either head or tail. You can tell this for sure. Now, let's consider the example of events which are non-mutually exclusive. So imagine that students can take math and statistics classes. So set M consists of all the students taking math classes, and set S consists of all the students taking statistics classes. So those two events, as you can detect, are not mutually exclusive. There is nothing preventing students from taking both classes. And as you can see on this illustration, there is indeed some intersection of M and S, and this intersection set is not empty. So there are indeed some students who take math and statistics classes simultaneously. So in this case, if you want to calculate the probability that a randomly picked student is taking math or statistics classes, you have to add probability of student taking math classes to the probability of student taking statistics classes, and you have to exclude this intercept. So this is what we discussed before when we analyzed the way we actually write down the unity set for two sets. If they are non-mutually exclusive, there is some intersection that implies that in order to avoid double accounting, we have to exclude it. So we add M, we add S, and this means that we already accounted for this intersection 2 times. That's why here we have to subtract it. Okay, hope it was clear. In the next video, we are going to discuss more numerical example, considering calculating probabilities, and thank you for watching.